Hi there. Thanks for joining, everyone. I hope this conversation will be fruitful for your product development efforts. So today I wanted to chat about an emerging product trend that's been especially prevalent in enterprise applications, but also in larger product teams. So let's talk about design systems. So we can start first with defining what a design system is and what it isn't, as well as the parts that it's composed of. Then I'll move on to why they matter, how they'll improve your overall product's usability. And then finally, we'll talk about their business value and how they help product teams operate more efficiently, ranging from design to development and scalability. So starting off, let's talk about what a design system is. A design system is a library of standard extensible components that create a consistent visual language paired with accompanied defined behaviors for each of those components. To break this definition up, there's really three parts. So there's the design assets, which are used for prototyping. Then there's the coded and styled components and their documentation, which includes design specs along with usage guidance. So we'll go into more detail for each one of these in a moment. Before we do that, though, let's clarify what a design system is not. So design systems are not pattern libraries or style guides or themes, even though they are sometimes conflated. All these design tools have predated design systems and have evolved to form what a design system is today. So that's why they're kind of easy to confuse. Pattern libraries are just the components themselves. Design systems have the coded components, but most importantly, they contain the guiding documentation to ensure they're used correctly and consistently. An analogy that a colleague of mine used the other day illustrated this, and what he said was, if you're building houses and you have the bricks you need to build them, it doesn't mean the houses will turn out consistently if you don't have the plans to assemble the bricks the right way. This really illustrates the point that even if you use the same styled components that you would pull from a pattern library, it doesn't mean that you'll have a consistent user experience if those components kind of aren't used the right way. So let's go through the design system parts in more detail. So here's the design prototyping assets. This is what a designer will use to mock up visual designs or clickable prototypes to test features with. Components are designed and added to the library, and then the library is shared among a team of designers. As changes are made based on usability testing or additional use cases may surface, components or patterns can be updated and then shared out. This example shows the Design System Manager in Sketch, which is one of the tools available out there. And it works quite nicely because you can upload updated symbols and then broadcast those changes out to everyone using that library, and then their designs will automatically update. Next is the component library. This is an example from a global financial data and enterprise software client we worked with. It shows the component, the code along with the parameters to configure the code for various options available for that component. And then once a component is added to this library, then any developer can grab it and not need to code it again. Just configure the parameters for that specific implementation. This too should be easy to make updates to because application code should reference this library, and then when changes are made, the connected applications should update. And then finally, the last piece is the usage and specification guidelines. These are very important to maintain consistency, not only around style, but interactions and behavior, which will have the most impact on usability of a product. Here are a few examples of the same component, a data table, across a few design systems to see them in practice. So for this specific example, this is material. You can see that on the left-hand side, they have documentation for specs as well as usage. This is an example of Atlassian. In the first section, which isn't on screen, they first describe when to actually use tables, and then they go into content alignment, dynamic tables, filtering, and actions. This is an example of our global financial data and enterprise software client's initial design system. Documentation is quite robust, but also unstructured. Therefore, it's hard to find what you need quickly without having to read the entire page. Due to the way the information was organized, the design system was translated into a different format that's seen here. However, this is now lacking bits of information about usage, structure, interactions, and patterns that were previously available because of its very strict information categories. Ultimately, there should be a balance between providing organized information, but also including all necessary information. For example, there's no documentation about the components that make up the table, like the table title, table actions, etc. So as seen with material design, their subsections are not always the same for all components, but that's okay because they're outlining the info available and then categorizing so it's easy to find. So really you kind of need to find the balance for what works for your product. So now that we know what a design system is, let's talk about why they matter. So design systems matter to product quality and usability. These three pillars build upon each other. They first begin with brand standards and design consistency, and those are the basics, which in turn creates a consistent user experience and expected UI behaviors, which then improves the product's usability overall. And we'll go into more detail. So here's an example of inconsistent components from an audit of our global financial data and enterprise software client. Here, the title and count for a table looks and behaves differently in each of these cases. You can see they're kind of highlighted in green, like the same component just displayed, styled differently, and it behaves differently across all these examples. So it makes it harder for the user kind of to find and recognize these common components. Varying and unexpected interactions can also cause confusion. So when unique user interface elements are constantly introduced, then cognitive load increases in parallel. This forces the user to encounter new ways to take the same action, which then forces them to interpret UI elements rather than focus on the task they're actually trying to complete. Here's an example of when consistent components and behavior work together to create a consistent user experience. In the top right, where you see the new job call to action, that's where we consistently have the ability to add an item to the current content on the page or page level actions. So in this case, there's only one, but when there are other actions, those are available there too. Consistent design patterns become recognizable when used repeatedly, and by reusing the same components consistently in the UI, then the UI becomes easier to understand and use. In turn, this reduces cognitive load. So what we found in usability testing is that when we showed this empty state to users, they actually click the button in the top right to create a new job rather than the get started call to action that's right in the center in this empty state, because the pattern had become so recognizable. It became kind of like just muscle memory for the user. And then here are some results that we had from additional usability testing after we improved the consistency of components, along with a few other things like testing new components and new workflows. It's important to test components and get feedback early and often before building these components to not only ensure a high quality product, but also not waste resources in coding something that may require a little bit of additional design work. So speaking of resources, let's talk about how design systems can help product development work more efficiently and what that business value actually is. So design systems create an optimized environment for product development. They allow for quicker prototyping by using reusable design assets and faster development time by developing the components and their respective behaviors once and then reusing them in a code library. Additionally, as products either grow in team size or additional enterprise products, design systems can support that scalability effort by sharing these tools that help design and develop quicker. Using these three factors, this expedites product iterations and also reduces design and development debt in the long run. So rapid prototyping, while still maintaining consistency, is possible when using a design system. This is an example of a base design system that's been created and has components that feed a global symbol library shared via the design system manager. As the design system evolves, updates can be pushed out to all the designers that use that design system manager. When a team of designers that work on entirely different applications for the same brand work off the same global design system library, it ensures consistency across all those applications. So having these pre-built components to use as the base helps accelerate the design and the iteration process because things aren't being designed from scratch every time. And this is an example actually of pulling a component right from the design system manager. You can see like how easily it is to quickly design something when those components exist. So you do have to have an initial investment up front to kind of build out your core design assets. But then once you build them, you're able to kind of iterate very quickly because you have this really quick base to pull from. So this is just showing you can kind of edit the data to make it contextual. Very quickly, now you have a table ready to go. Oops. All right. And so design systems, they don't only reduce design debt, but also development debt. So once these components are built and stored in a development component library, other developers can then grab them and insert them as their needs arise. Options should be built into the development of a component so that it can be configured to accommodate different states and also be extensible for future use cases. Obviously, you won't know every future use case, but kind of the more that design developers and product can kind of collaborate on this and kind of think about the potential future use cases and try to build what you can think of ahead of time, the better off you'll be for future iterations. And then the reusable nature of this configurable development component library reduces the technical overhead since these components are built once and then you're pulling them as you need them. So the reusable principle of design systems kind of make it easily scalable. Since a design system is a collection of reusable components, these components can be extended to any team or application. However, the scalability is not limited to the visual design or the development efforts. The standards and documentation in a design system around usage and behavior will guide the intended user experience and then remain intact when scaled, whether it's scaled to multiple products or just one product that's growing quickly. It also scales the knowledge base in general since all users have access to the documentation and tools. So then you're also getting rid of knowledge silos. So all in all, design systems, they're a powerful tool to help businesses scale with a solid foundation to reduce future design and development costs, as well as support a consistent and positive user experience within the usage of their products.